I cannot speak yet Indonesian, but I will try to speak very simple English so everyone can understand me. And perhaps today it will be interesting topic. Beam for bridges, the second part is interesting, wish or reality. We are talking a lot about beam, but is it really beam, or it is just transferring from one product to another one, or is it really one model where we can store all the data? I will first just say a few words about company, where I'm coming from. Nemetschek, Allplan, and Allplan Infrastructure. We will talk about optimal bridge beam workflow, and then on the end about the very innovative bridge beam solution, which is a composite of Allplan Bridge Engineering and Beam Plus, which I will present you also and especially tomorrow in our workshop. So Nemetschek Group, first of all, is worldwide the second largest architecture, engineering, and construction software company, more than 55 years on the market. The daughter company, Allplan, is a very special company because it is the open beam solution, developing open beam solution for architects, engineers, and especially in the last time focusing in the infrastructure. I'm coming from Allplan Infrastructure, which is much smaller, but it is specialized in bridges, development, consulting, and we have some history about some projects worldwide as well. So, you have seen this picture for many times, where you have the information model in the center, where you have the workflow between model, analysis, design, and construction. And here I always say, sometimes there is indeed the wish to do this in the way how it is written down, but is it really worldwide nowadays the situation? I can say it is in Allplan solution, the only one, which is my honor to present you here in Indonesia, after we presented it at the APSE conference in New York 2 months ago. So why should we have one model? Because first of all, we can exchange the data in the same model. Let me say, we don't need to transfer, we don't need to deliver many models and exchange them during the process of life cycle. What means we have a kind of cost security during the project, and we are not implementing a lot of errors. I presented one paper at the APSE conference on a real project, and in this real project for such a bridge, which was a real project in Northern Europe, 4 different models have been used. The model for the bridge, the model for the pre-stressing tendons, the model for the drafting, and the model for the analysis. Of course, there was somehow a link over the file transfer, but due to those file transfer, this was occurring the mistakes, the delays, and of course, losing important information. I'm presenting today the single model, which is used for modeling, analysis, and for the detailing in once. This is Allplan Bridge Solution. In this model for the infrastructure for bridges, you have in the parametrical model hidden everything, the detailed information about the bridge, geometrical information, which are very important for the later detailing and drafting, but on the one hand, it is also the analytical model at once. So it means you don't need to transfer those data in the other model as well. And this one is, let me say, not only three-dimensional, but it is also four-dimensional, so it means that the time schedule is embedded in the process, because we know that bridges are built in the time schedule and you need to consider the time activity as well. Let we see a very, very short teaser which we presented, so it's perhaps more interesting to see this. So this was just a short overview what is hidden in this solution. Means the most important what bridge engineers are facing nowadays are during the design, several changes are happening, modifications, and those modifications need to happen in many models at once, at least two, what is delaying then the process. Software is a bridge-oriented solution, means we have a combination of the axis, structural cross-section, and the variation, the structural member, which can be the girder, it can be the pier, it can be, of course, different types of piers, but it can be also very detailed, as you can see, the rail tracks, the extra dose bridges, the precast segmental bridges, so any shapes and any types of the bridges. In this case, we are able to make a very detailed presentation of the anchorage heads, precisely definition of the bearings, rail tracks, wind barriers, and of course all those parametrically exchangeable if the changes are happening in the bridge. Many bridges are always also combined with the pre-stressing tendons, might be internal, external, where we need to think about many of them. So we should use the intelligence within the software, means that the software should know where the pre-stressing tendon is placed. It can be also copied, moved, so any manipulation of those tendons should be very easy implemented. But not only modeling, means we would like also to have the efficient calculation of the stress losses. And this is embedded, means the software will predict or suggest such a form of the pre-stressing geometry that the stressing, wet slip, release produce as less as possible stress losses. And as we are the complete solution means that these pre-stressing tendons needs also to be drafted. And this is also done automatically in the same solution, so with the eccentricity automatically produced in Allplan as well. We were talking about the construction sequence definition, and here the bridge engineer is very, very free to define how the bridge will be built. So it means you are on the construction site, you make some changes, those changes can be directly implemented in the same model, and of course, due to those changes, there will be also changes in the results, in analysis. So it means you can directly also produce some different construction sequence schedules or variants, and even combine which would be more favorable for your bridge type. So in this case, you are following a process of the bridge. You can produce such performance movies to control what is happening with your bridge. Now, we were talking that this is the project, this is the software, this is a solution which can automatically derive the analytical model from the geometrical one. We know there exist a lot of solutions which are very good analytical software, but the problem is in the analytical model is always simplification of the geometrical one. We need to start on another side. We need to start on the geometrical detailed model where we need those details for the drafting, but not for the analysis. So it means that we are now talking about details on one side, but on another side, simplification analytical model, which will be used for analysis and results. First of all, we need to get the cross-section properties detailed, calculated, should be user-friendly, should be also checkable. On another side, we would like to have calculation of this construction sequence, which should be automatically done, but on another side, the bridge engineer should not have a black box. He needs to control what is happening with the bridge. It means that we have a kind of load case generation which was added, which was understood as a load and not a structural element, as a self-weight due to the time schedule, creep, shrinkage, relaxation. Due to the definition of the pre-stressing tendons, it is automatically assigned to the structural members. And so on this way, the loads will be automatically prepared. On the end, we would like also to get the results presented, so analytical results, bending moment, shear forces, stresses, and so on. And this is possible also to do for any type of internal forces, primary, secondary, globally, locally, and present in such movies, so you can always check and present to the project owner what is happening with the bridge. So we are talking about money, and money nowadays is an important fact for each bridge construction. So it means if we have such a solution, then it's very easy to prepare many variants of the construction schedule. If the bridge will be built stage per stage, or the bridge will be built like cantilever or incremental launching, so you can always use the same model, but activating on a different way. And on this way, you can compare the costs, and you are very efficient, of course, during the time, and you can optimize your construction. I was telling you that there is a certain intelligence used in this model. What does it mean? It means that if you define in the cross-section what part of the cross-section is used as a structural part, and what part is used as a non-structural part, then automatically the superimposed dead load will be assigned. So you don't need to calculate anymore the area, center of gravity, and so on. So everything is happening just automatically. And loads are so automatically applied at given time. Very innovative here is the superposition. All bridge engineers, we know that the loads are not enough. We need to combine those loads with the different factors, favorable, unfavorable, in superposition files. And those superposition files here are just very interactively, user-friendly, combined one to each other. The green are load cases, the blue are superposition files. You can change those extremely easily, and this is time-saving, it is overview, and always changeable. What is extremely important is that this bridge model is not split from the detailing part. It is the same model. So all those details which we created in the geometrical model, we will now supplement with the necessary reinforcement, which is three-dimensional, and you can work in two-dimensional or three-dimensional space. It means extremely important that you deliver also very, let us say, quality drawings, that you can choose between different international standards, and that you check in case of so heavy reinforced elements, also the clash. What is especially good in this solution, you can intelligent use the data organization, means it is possible that many engineers are working at the same time on the same project. It can happen that the bridge project is quite long. One engineer is starting to work on the segment 1, another one on the segment 30. And they do not need to copy, paste, and check if there has been the old version saved or not. They can just work on the same version, on the same database, and the database is intelligent enough that it knows this part of the bridge is now used by another person. It will be visible, but it will not be changeable. Sometimes, you know, user has a problem, engineer has a problem because he would like to make some changes, and those changes he needs to make them in 2D, in 3D, but not in this case. In this case, when he's making a change in 2D drawing, it will be automatically done in the three-dimensional model as well, and opposite. So in this case, you always see what is happening if you are touching one part of the bridge, for example, pier in this case. All the parts which are visible in 2 or 3D views will be marked. So it means this is again lack, not necessary that you make any mistakes in this case. For bridges, which are very complex structures, of course, we expect three-dimensional complex reinforcement modeling. Means that the curvature of the three-dimensional reinforcement can be any type. I have chosen here some extremely changeable reinforcement forms. We know that architecture nowadays is getting more and more crazy, let we say. And of course, the bridge engineer needs to follow those forms. And here it is important that the reinforcement bar is following the shape of the body. We have, of course, as mentioned, many very well-known bridge engineers, company consultants worldwide. One of them is also Leonhard André and partner from Germany, using Alplan in the project, which is well-known, Queen's Ferry Crossing, where the pylon, the concrete pylon, was narrowing, and that's why extremely important was the checking of the position of the reinforcement bars. Or another one, which has been finished in Switzerland, so it was really important to have visualization of every bar, also a difference between the bars, reinforcement bars and pre-stressing tendons. So visualization is indeed very important. I was mentioning parametrization, and parametrization in Alplan Bridge has been shown by changes which can happen anytime, and updating will be done in analytical part, in geometrical part, but sometimes, you know, you always have elements which should be prepared in a library, fully reinforced, and then just used for similar type of projects. So in this case, we are using Python parts and also visual scripting, which is at the moment quite efficient situation for bridges. Bridge engineer needs quality drawings, so drawings, reinforcement drawings, and of course, beside this, we need also different reports, bar bending schedules. And now we are coming to the last cycle, which is open beam platform. This is Beam Plus, where we can exchange the data between different multidiscipline project teams. It is open. It is free of charge to certain project space. And due to the fact that Alplan and Nemetschek is pioneering open beam solution for many, many years, we are following up this in a very good manner, that the user can very simple but efficient exchange the information between the project members via cloud platform, exchanging the tasks. It is, of course, IFC attributes compliant, and you can always assign also your own IFC attributes. So I would now conclude my presentation in a manner that the solution, which you have seen here, has in the first line a big plus due to the one model for geometry, analysis, detailing, open beam platform, not closed one. Due to the parametrization is extremely efficient and time-saving. I always say, without technical support of experts, bridge engineers, no solution is really good. You need this, and we can offer this. And this approach is giving us one beam model, of course, which is then resulting in the design reports, structural drawings, and of course, some detailings as well. I would say BIM is not yet implemented in every company. It is a little bit different workflow as conventional one. It needs to be somehow decided by the management, but with the right tool, of course. And especially in the infrastructure, there is nowadays, due to the projects, due to the type of the bridges, sometimes a question which solution should be the best one. And I would say, in this case, The management needs to decide, needs to trust, and needs to be willing to start with the beam. And I'm very happy to hear that in Indonesia, this beam is going extremely, extremely well. We have been traveling a lot worldwide, but I can just say congratulations to Vika on this space. Thank you.
Thank you, Ms. Vanja. Please